In this video, I'll talk about stabilizing winding, which is also known as buried delta winding. So some people might refer to this as tertiary, but as I explained before, there's a difference between stabilizing and tertiary. Stabilizing winding is there just for zero sequence and also for triplen harmonics, 3rd, 9th, and 15th. Tertiary winding, actually the winding is carrying load, so it's loaded. So there are differences. So previously I spoke about winding insulation resistance. Now I'm going to talk about winding resistance. These are two tests you can perform on the stabilizing winding. So this delta, basically you have 3 coils that are wound separately. So then what they would do, they would connect these 2 terminals here. So basically, you have start finish of each coil. Then you would connect. Now, so you connect 2 terminals, then the 2 corners of the delta. The third one you would not connect. But first, let's just kind of recap. So when I talked about insulation or winding insulation resistance, so basically, if you imagine this is kind of the tank, then kind of looking from the top, and this we're showing the delta is inside the tank, but just keep in mind there are other things inside the tank, the primary, secondary, core, all other things, but I'm just showing the stabilizing winding delta just for simplicity. So you would so before we said if you want this test to be performed, basically you connect this terminal here or these 2 terminals to then you bring the lead through the bushing, then you ground this bushing externally rather than internally. But to perform this test, you have to remove this ground jumper. In other words, the bushing has to be disconnected from the ground, then you perform the test. Now with the winding resistance test, you actually are, instead of insulation, you are measuring the conductor resistance actually. So again, you have 3 coils or 3 windings. So again, you kind of join these two. The third one you do not. So again, let's assume this is a tank. So then in this case, you need 2 bushings. So what you do, so you have 2 terminals here. So you bring one here, bring the other one. So in service, basically what you would do, you would jumper these 2 bushings, like a bus bar or a stranded conductor. Basically it's a conductor. Then you take this and you ground it. So you still have a delta with 1 corner grounded. Now to perform the winding resistance test, you have to remove this jumper here to ground. And also you have to remove this jumper that jumpers the bushing. So basically what you end up having is something like this. So these 2 are jumpered together. Then you have the bushing. So then what you do, you apply DC voltage. So as the DC source, you connect one side here, the other side. So when you apply DC voltage, the circuit is complete, so current will flow. So it's going to go through this winding. then through this winding, then through this winding, through this bushing, and back to the source. So there's a complete circuit. So then from Ohm's law, the resistance is just VDC divided by IDC. So you'll measure something in ohms or milliohms. It depends on how big or small the conductors and number of turns and the length of the conductor and other things. The only thing here, so if I call this phase A, for instance, phase A, phase B, phase C, this resistance here will be equal to the resistance of phase A plus resistance of phase B plus resistance of phase C. So we don't have a way to measure individual resistances because we only have access to one corner of the delta. We don't have access to the other corners. So obviously, if you want to do the individual resistances, you have to bring all other corners. That means you have to have 6 bushings, which now, one cost, because bushings cost conductor, plus they have to be mounted on the tank, so there is so that you need more space, plus other things, so that's why probably people are not going to do that. But this is at least, you can, if you specify the transformer to have 2 bushings with one corner of the delta brought out through these 2 bushings, then you can ask for the resistance to be measured at the factory, and you can use that value as a baseline. Like when you do routine maintenance, for instance, in the field, you can measure this this total resistance and kind of compare it to the test report. So these at least 2 tests you can perform in this on this stabilizing winding. So there's winding insulation resistance, this winding resistance. You can also do power factor test, because the issue here is, so I'm just going to give a hypothetical. So if you have a large transformer, for instance, let's say $4 million it costs. So the high voltage winding and low voltage, they will go through extensive testing. It depends on voltage. If it's more than 300, if it's like, for instance, 345 kV, you're going to have switching impulse. The rest other tests, you're going to do lightning impulse tests induced with partial discharge test, a high voltage applied test or high pot, winder resistance, ratio, power factor, heat run, all other things, So it's a very extensive testing. So unfortunately, the stabilizing winding, if it's grounded internally, for instance, there is nothing you can do actually. So imagine you have a $4 million piece of equipment. So this here could be the weakest point, for instance, because all these transformers are made by, there's workmanship, it's people making them. So, and mistakes happen. Sometimes it's design issues, sometimes it's workmanship issues. The only way to prove that or make sure that there is nothing wrong is through testing, So high voltage, you can verify low voltage, but stabilizing winding, if you don't bring at least one corner, so there is no test you can perform actually. So imagine $4 million and no test, is done to check, So by if you bring at least one corner, you can do winding in insulation resistance and power factor, insulation power factor test. If you bring 2 bushings, you can add another test, which is winding resistance. So at least some kind of checking, make sure that this winding is designed properly. Thank you and have a great day.